Welcome back to my channel. Imagine a world where AI agents collaborate like humans, communicating, designing, coding, and testing with minimal errors. But how do they handle miscommunications or hallucinations? Enter ChatDev, a groundbreaking framework that streamlines communication between AI agents. Let's dive in. ChatDev uses a chat-powered framework to integrate agents with various roles from CEO to programmers and test engineers collaborating in different phases. It uses a chat chain to break down each phase into smaller subtasks and guides multi-turn communications between different roles to propose and validate solutions for each subtask. To alleviate hallucinations, agents request more detailed information before responding, reducing coding hallucinations. ChatDev uses a chat chain with sequential phases including design, coding, and testing. Each phase consists of sequential subtasks. For example, the coding phase is subdivided into code writing and completion, and the testing phase is segmented into code review and system testing. In every subtask, two agents act as an instructor and an assistant. The selection of the two agents depends on the nature of the subtask. For example, in the design phase, the CEO is the instructor, while the CTO is the assistant. In the coding phase, the CTO is the instructor, and the programmer is the assistant, and so on. The instructor initiates the instructions, and the assistant responds. When ChatDev receives a user prompt, such as design a 2048 game with a 10 by 10 grid, it first generates a series of structured prompts to lay the groundwork for the demand analysis phase. Next, the CEO initiates the conversation. Then the CPO replies. The CEO responds to the CPO, concluding the demand analysis phase. After the CEO and CPO reach a consensus in the demand analysis phase, ChatDev generates a new set of structured prompts to prepare for the language choice phase. The CEO then consults the CTO to request a recommendation on the programming language, with the CTO now acting as the assistant. The CTO responds to the CEO, selecting Python as the preferred programming language. The process then transitions to the coding phase, where the CTO consults the programmer, requesting code implementation, with the programmer now acting as the assistant. The CTO initiates the conversation with the programmer. And the programmer responds to the CTO. Instead of rushing to a solution, ChatDev ensures each phase progresses iteratively. Solutions from earlier steps are passed down, making the process more cohesive and error-free. In standard AI workflows, if an agent misunderstands an instruction, it guesses, often incorrectly. ChatDev addresses hallucination with communicative de-hallucination, where the assistant first asks for clarification before responding. Here's how it works. The assistant temporarily takes on an instructor role. Instead of generating an incorrect response, it asks for more details. The instructor then provides more specific details. The assistant refines its response based on the instructor's feedback. This process significantly improves code accuracy. To evaluate ChatDev's performance, GPT Engineer and MetaGPT are selected as baselines. Currently, no publicly available dataset exists for textual software requirements in agent-driven development. To address this, the ChatDev research team is developing the software requirement description dataset, combining LLM-generated examples with human refinement, covering 1,200 task prompts across 5 main categories including education, work, life, game, and creation. ChatDev and the two baselines are assessed using 3 key dimensions: completeness, executability, and consistency. These metrics are then combined into an overall quality score, reflecting the software's reliability and minimizing the need for manual intervention. Software development is divided into 5 subtasks across 3 phases: with each subtask concluding after 2 unchanged code modifications or 10 communication rounds. Communicative dehallucination is applied during code completion, review, and testing subtasks. ChatGPT 3.5 and Python 3.11.4 are used for feedback. The evaluation result shows that ChatDev outperforms all baseline methods across all metrics, particularly in executability. ChatDev achieves significantly higher quality scores than baselines by allowing agents to autonomously propose and refine source code through continuous dialogue in both natural and programming languages, rather than relying on predefined instructions. To better understand user preferences, human participants and GPT-4 compare pairs of agent-generated solutions to determine the preferred one. ChatDev consistently outperforms baselines, achieving higher average win rates in both GPT-4 and human evaluations. Although multi-agent development is slower and consumes more tokens than the single-agent approach, it produces a larger codebase with more lines, enhancing software functionality. The ablation study examines key components within DevChat's framework by removing selected phases in the chat chain, communicative dehallucination, or the roles assigned to all agents in the prompts. The results shows that code complete phase enhances completeness, with testing critical for executability. Quality steadily rises with each step, suggesting that software development optimization is progressively attained through multi-phase communications among intelligent agents. Meanwhile, eliminating communicative dehallucination results in a decrease across all metrics, indicating its effectiveness in addressing coding hallucinations. Lastly, the most substantial impact on performance occurs when the roles of all agents are removed from their system prompts. Without roles, feedback tends to be high-level, leading to limited adjustments by the programmer. This finding underscores the significant influence of multi-agent collaboration on software quality. ChatDev showcases the power of multi-agent collaboration in software development but has limitations, such as overestimated capabilities, a need for detailed requirements, and a tendency for simplistic logic. Evaluating software remains challenging. Multi-agent collaboration requires more time and resources, increasing computational costs. Future improvements could make this approach more efficient and practical for real-world applications. If you enjoyed this deep dive into AI collaboration, don't forget to like and subscribe for more AI research breakdowns. Thanks for watching, and we'll see you in the next one.